So the presentation will be delivered by Dr. Xiuju, Group Manager, Institute of High Performance Computing. Dr. Fu, please.
Good noon. Every time, actually, the morning time passed already. I'm Xiuju from A-Star HPC. Just now you see two of my colleagues. You see how deeply we are developing in maritime traffic research. So today, on behalf of the team, I will share some thoughts and some development in these next generation VTS systems. Yeah. So this is the agenda. So I don't go through that. Yeah. So actually, we don't need to repeat that much about the traffic safety's importance for Singapore, because we are one of the most busiest hub, and also Singapore Strait is accommodating 1/4 of the world trade throughput. So every year. So and Singapore is developing the mega towards port to accommodate the increasing of traffic throughput. So when we are facing with this increase in the traffic, so-called, and also our operation capacity, we are also facing to the challenge. More traffic come through, more vessels come through, more complex kind of interaction also coming to us. So we need to enhance our vessel traffic management capability. So that's a requirement for ATS to further develop. At the same time, we are also facing to the aging trend in Singapore, also worldwide, right? So we need to help the operators to enhance their capability, reduce the tedious human work, and also just now the human factor, right? So that's why we are developing this concept and also develop prototype models. So with the support from MPA and many industry partners along the way. Yeah, so if we look at further, for this VTS, if we want to transform that, in our view, actually we have the framework design, and if you want to see the full version of this concept, you can see our latest journal publication. You can search online, just use the keywords, passive to proactive, you can get our paper already. Just come online in this February. So for this VTS system, next generation one, we foresee some critical capability should be established. So if we see here, first we need to take the big data in, we can really take in and use it. And we can further establish the knowledge base and use that to train the AI capabilities and provide the service intelligence all along the way. Then although you have the intelligent model, you still need to work closely with the operator. So the human-machine interfacing is also very important. So with that, we can introduce the so-called transformed features, also called innovative features, for us to transform and help the busy port like Singapore to manage the traffic safety better. So let me elaborate more how we do and how we can establish this kind of capability. So the first one is about big data processing. So how it means. So because we see a lot of sensors, data from various systems are generating. So it's like a human, you are taking in the food. This is the big data is the food for the system. So you take in, but you need to take the right one. If you take the so-called arrow one and you cannot really consume it, you get poisonous and you get sick. So you don't want to really use it. So this big data processing capability is very fundamental things for the maybe future VTS to establish along the way. So HPC have spent quite a lot of efforts to connect the data from multiple sources. It's not only AS, you have the port management information system, operations, data, the device of particulars, all the things actually is matter and help us to establish the intelligence for the system. Yeah, so with that, after we can really consume the right data, then you need to really digest it to get the nutrition part. So one of the key nutrition part we are highlighting here is So the team working very hard to get this kind of framework. So you need to establish so-called the knowledge bank we established just now. My colleague Xiao have introduced the traffic hotspots. So we need to establish the historical case so we can quantify from there. Traffic hotspot, multi-vessel encounter, kind of hotspots. Near miss case later I will introduce more. Waterway patterns, you can see that. Doesn't work. So also the port operation patterns. So a lot of this knowledge base is what you can extract and establish as the essential information for humans to compare the normal and abnormal pattern. At the same time, for the machines, intelligence machines to learn, train, and verify to ensure they can really provide the intelligence for operators to make some decision. So, okay, I will go further. So one of the example I can share here, now we have quite many so-called knowledge base. So one of the knowledge base we introduced is a near-miss case knowledge base. You see the video is playing similar like what Xiao just saw. This is the knowledge bank we built over the past 3 years, similar interface design. So the near-miss case, first we should be able to detect it. So we have the near-miss case detection model. And so we also define and quantify, also take in the domain experts inputs. Near-miss almost collide one step from collision. And compare with the incidents, so it's much more cases. And if you look at, we don't have too many incidents in Singapore Street, definitely they are doing a good job. But if we just look at the incident itself, actually they give us the bad example. The things get worse because collide. But if you look at the near-miss case, it's one step away from the collision. It shows the so-called the risk is reached to some extreme level, but at the same time, they manage to avoid the collision. So if we can look at this is represent more of the collision, the so-called collision risk dynamics, because they have more, and also shows us how the story goes to the better end. So if we can use that, establish that, the people can have the daily report about every day how my street is working and how my maybe operator is performing. Do they experience stress? And on the other side, my AI model can take in this the near-miss case. I can incrementally increase them because the data stream coming in every day, right? So if anything change, they can tune maybe the manpower allocation or the AI models to learn more. Oh, this is a new pattern established. I should notify this risk with my the center and so on. And also maybe autonomous vessels can also test how well they are working for the street of busy water like Singapore. So we can imagine quite a lot of interesting usage. So that's the case we show the two vessels come very close, then leading some strange behavior between vessels means they didn't really follow the original intended trajectory, almost collide. And if you look at the case, this is a series of events happening. And when we look at them further, you can break down into different steps and sense what happens behind it. So you can imagine, you can use it further. It's a rich information there. Yeah. So this is one typical of the knowledge base we are talking about, and how really come from the raw data, go to the so-called nutritions for us to build up our next generation VTS. Okay, so after you have this kind of a knowledge base, let's say we are talking about how we can advance our collision risk warning. So one of the examples we show here is our AI-based risk warning. But when we talk about the risk, also what risk means for Singapore Street, how much the threshold and how we are tolerant with certain kind of risk. Just now, we say this near-miss case plus the incidents is representing the collision risk we are facing every day. So this risk warning model should be able to predict such kind of risk based on this near-miss case we present to you just now. If they can work for that, means in the real traffic, they can help us to pick up those prominent risks, and we can trust it. So that's the verification, right? But when we build the learning model, we also use the training side to build the capability of learning. So this video shows that based on our AI based risk warning, we can predict these two vessels encounter situation around 5 minutes earlier compared with the traditional linear trajectory-based risk warning. So what that means, 5 minutes actually matter a lot. In reality, that's very short. But for two vessels, if we really want to avoid the collision, 5 minutes give us quite a lot of time for the vessels to communicate and make the right actions, right? So this is one example how we, from the data processing knowledge base, and then we build some intelligence on top of that. So this one shows the another type of the prediction. Just now, Xiuju have shown our hotspot prediction. So I just replay. Maybe I don't go deeper about that. So this is another angle to look at the traffic situation. Just now we say collision risk. You want to see it 5, 10, 15 minutes, but you want to see, because we are very busy, the traffic street. Then we want to sense the situation, so maybe the senior watch manager can oversee the situation. What I will, where is the traffic is building into the dense situation, and also maybe is they turn into the multi-vessel encounter, or that's vessel coming in and out, we're going to join in this kind of a traffic, east and westbound. If they just follow the lane east-westbound, it's just busy traffic. But if you had a vessel want to cross, cut in, then you are interfering, you are disturbing this traffic, you may get some trouble. So for the senior watch manager, no need everyone to look at this view because they are very busy for the immediate task. So this one can give the watch manager some view about this situation, whether they should help the junior operator to manage, or they should form them to pay attention to certain situations which keep building up. This one is a multiple scale. Well, what I mean is, so it's not just look at 30 minutes. It's, you can see the things moving or changing or updating up to, say, now, 5 minutes later, how it look like, 10, 15, until 30 minutes. So it depends on who is looking at that. The algorithm is able to automatically feed in the different time kind of outputs to the different, based on the role of the operator. This is something we are generating during the research. Yeah. So just we show some of the example just now about, sorry. Okay, there's 3 videos supposed to play together. Doesn't. It's an inclusive picture to show if after we have the big data processing, take in the data, we digest it into the nutrition of our knowledge base, and then we have the intelligent model to help us to enhance the service. And then we go to the human-machine interfacing visualization. So you have, we don't want to make too crowded for the operator to see all the information. They've been coming in different timeline. And also besides just the visualization, they also have the text to be pushed up to allow the operators to receive the right message, suggestions about the next action. So you could see something up to 10, 15, and multi-vessel encounter also maybe up to 15, 20, and traffic dense hotspots up to 30 minutes. And all of that is tell us how the dynamic traffic is keep evolving in our Singapore street, and it's linked with the so-called, definitely the most critical one is our safety. Make sure the vessel goes through us with a smooth and safe trip. And another one is if we can avoid those arrival and departure vessels to enter into the so-called traffic dense situation, then actually it can save us even fuel consumption and the stress level both from vessel side and POCC side. So you will see the efficiency linked with the port operation is also present there because it's a connected system anyway. So and this is the whole concept actually we are developing during the past few years under the support with MPA, as I mentioned just now. So we are going to keep so-called enhance and go to the test bedding phase, and we welcome the collaboration for our research. So as a quick summary, for the next generation proactive VTS development, from our view, we see it's like a EDB kind of a development. So it means we need to extend the operator's memory capability. We cannot trust on our own memory. For me, I feel I need some assistance for enhancing my memory. Maybe meet the people, especially with the facial mask, I cannot immediately recognize. But you know, Apple, the phone, they can say, even you have the face mask, they can recognize you. I just give an example. So for POCC operator, they need the memory means the data is there. They have all this kind of so-called knowledge, what happens in the past. The history may repeat itself majority of the time. So can we allow this kind of knowledge base to be extracted and annotated, then help the POCC operators to really pick up the situation, normal, abnormal, or some things I need to do further. And another one is help them to advance the existing warning system. They can help to reduce a little stress because the daily busy traffic is really stressful. We have been there in the morning, 6:30, we see how the busy traffic there are. They keep communicate with the vessels. So help them to reduce the burden, attract more of the young generations to come in. So help them to get more reliable, accurate, earlier warning. So that will help us to develop the VTS system. Also, need to keep defining more of the intelligence features, like the situational awareness. Depends on the traffic situation, either in Singapore or any part of the world. And also, we need to breathe in the intelligence and the part of the automation through the intelligent models. Then we can reduce the manual workload and also the human errors. Make sure really the intelligent models as an agent to assist the operators, like your left hand, really help you to make the decision and reduce their workload. So all of that is our thoughts. Definitely a lot of other things may come in. And we also foresee that maybe with the VDS, either terrestrial or satellite, we can have more data come in to enrich our VTS system development. For example, if you know vessel's engine information and two vessel encounter once in the, you need someone to really quick maneuver. But the ship engine information tell us the vessel have problem. They cannot do that. Then you might not advise that one, even it's break the correct rule or whatever. So I just give you an example, maybe the domain expert need to comment on that. So that information will help us do better and maybe more safer kind of a decision for the right and safe traffic. And also, you know, the data come in, the models keep taking in the data and more complex. Maybe the heavens computing also need to come in to help us to do the computing. And finally, just now my colleague Kenneth also shared cognitive computing part. So in the future, maybe the VTS can be some way like our Siri. Hi, morning. Yesterday you had the bad experience. Maybe today I try to help you to sense the traffic situation. So it be more interactive with the operator and work more closely. So just a brief share some of our thought. This is my last slide. And thank you. So welcome the collaboration, and feel free to write to us. And we are also establishing the Maritime Air Program. It's on the way. So also continue the maritime traffic safety research using big data and AI. So we welcome collaboration, question, and queries. Yeah, thank you.
Yeah. Thank you, Dr. Fu. I think in the interest of time, we will not be able to have any Q&A. So if you have any question for Dr. Fu, please feel free to approach her during the lunch and networking session.